Today we are in chapter 7 of sampling analysis, and we're going to talk about calibration. Every day at the laboratory, I go in, I turn on the pH machine or the pH meter and the DO meter, and I let them warm up for about 5 to 10 minutes. Go around the lab and take my temperature readings, and then I will air cal the DO probe. And then I will put a set of standards for uh, 7 and 10 on the pH probe, and I will calibrate the pH probe. This is required by the EPA and standard methods to be required every day, or I believe it's every shift. We only work one shift at our workplace, but you need to check with the EPA if you have a morning shift, a mid shift, and an evening shift. It's never a bad idea to calibrate it each shift. Every time a new operator comes in, it's never bad to calibrate it. But in your journey as a water and wastewater operator, you'll constantly be doing calibration checks or calibrating the meter or quality control checks. The reason why is we want to make sure that the information that we're sending out is accurate and representative of what we have. We as operators are responsible for discharging clean water out to the streams or the body of water that you discharge. And on the water side, we want to make sure that our chlorine meters are reading the proper amount of chlorine, especially if we're on that lower end of keeping the chlorine in the distribution system. We just want to make sure that we are keeping the community safe and ultimately the wildlife safe. On page 111, it says quantitative analysis requires the use of standard and reagent solutions of known concentration. In general, it is a poor analytical practice to prepare a solution and to use it without verifying its concentration. The reason why is first, no chemical is 100% pure, and many chemicals are available in a range of purities, which may or may not be correctly stated on the label. So just because you get a solution or a reagent or a standard from the manufacturer, uh, mistakes happen. People are human. Things could say that they're 100% pure and they're not. So uh, throughout what you do, you're doing constant quality control checks on the chemicals and reagents that you were using at the lab, and then constantly checking your meter. So things can happen to your meter, dust, vibration, age of the meter, that where it can fall without outside the lines of its calibration. So you constantly, a lot of the probes, they'll have a gel in it. They can the end of the pH probe or the ammonia probe can get biofouled. Working in water and wastewater, as much as you try to be careful when you're transferring liquids, it can pick up air, dust, and so we're constantly in a state of checking stuff. So direct standardization on page 112 is an example of direct standardization is ferrous ammonia sulfate titration of total residual uh, chlorine using, I'll call it the DPN method as an indicator. So direct standardization, you're just using one other thing like ferrous ammonium sulfate titration. Sorry for going over these, a lot of words. You're just using one thing to standardize what you got coming into the laboratory. Indirect is you have multiple steps, multiple things, because many reagents, and it says this, many reagents do not react directly with an existing primary standard. So you have to add multiple steps and use your knowledge of chemistry to indirectly standardize a chemical coming into the lab or a solution that you made. Solutions lifetime. Reagents and standards for quantitative analysis have a limited shelf life. For many reagents, the lifetime is given in the method. However, for others, the maximum life of 1 year is assumed. When we get reagents into the lab, one of the things I do is I get the bottles out and I will write received on 223 of 25. And then when I open them, I'll put opened, and let's say I'll open it in May, open May 5/13, 2025. So um, you want to make sure that you're not exceeding that shelf life, just like you would any kind of food product that you have coming into your house. Same way with the laboratory. It does have a shelf life that it can it expire. And so every time in your lab, keeping that, it's nice to keep that in a book. So when you receive it, you mark that in a book or set a reminder on your Google Calendar or alert on your phone. So within a year, you get an alert saying, "Hey, this reagent or this solution has expired. It's time to get rid of it." Calibration. So, page 114. Calibration consists of establishing a relationship between the analytical response of a test and the concentration of a target analyte in the sample. This is done by testing samples of known concentration of the analyte and recording the analytical response. The analytical response, for example, may consist of a voltage, resistance, or current difference between electrode and the reference, a decrease in the amount of light of specific wavelength passed through a solution, or number of milliliters of titrant required to reach an endpoint. A lot of your meters will be measuring some sort of electrical connection or resistance, just like it said. So on, let's take pH for example. I put a 4 on it. I see how the meter responds to a 4. I see how a meter responds to a 7. I see how the meter responds to a 10 standard, and I'll put that the machine will actually do it. Back in the old days, you would have graph paper like is on 115, and you would chart that out. The meter does it for itself, and that'll give us a slope. A slope is the correlation between that 4, 7, and 10 versus the meter. A good slope, which will be in the documentation of the meter when you get it, means that you can proceed with your test. A bad slope, you need to restart that process over so that you can attain a reliability. Meters can be really temperamental. The probes, it talked about a probe uh, in the bottom there. Um, Probes go bad, voltage readings get skewed, and so sometimes, as an operator, you can really fight with a meter. So it's good. It's important to have a backup meter. Um, to have so that you can send that meter out to the lab. I know they're expensive, but it is good to have a backup meter. So you have 1 point calibrations, which is self-explanatory, and then you have several point calibrations. You can see on page 7.3 and 7.4, you kind of see that line graph that we're talking about and the calibration curve. Uh, and it goes on and explains just all about those line graphing and calibration sets. It's important that on one page 127, a separate calibration should be performed on each instrument used by each analyst before the test. Calibration data and graphs should be labeled with the test performed, the date of the calibration, the name of the analyst, and the instrument if applicable. Check with your EPA um, if that is something they want to do. Normally, like for us, one person will calibrate the pH meter in the morning, and then we all use it. But what we do is every 10th or 7th standard, whatever the EPA requires, if we run, let's say, a pH sample and it comes out to 7.83, we'll run a duplicate, which means we'll run another sample that is of the same concentration, same um, sampling technique used, and we'll match what we get. So if one sample comes out 7.83 and the next one comes out 7.97, we know that there's something wrong in our testing because we grabbed that sample from the effluent, we handled it the same way, and we're getting two various different results. Um, Another thing that we'll do with calibration is we'll calibrate the meter, and let's say we do like a point 0.1, a 1, and a 10 for the ammonia standard. Then we'll check it with a 5 and make sure that that ammonia meter is reading what it should be. Um, and it goes on 129. The best way to monitor a calibration is to perform a calibration check, which is what I talked about. Calibrations is important for water and wastewater laboratory. When you get out into the field, each instrument will have a manual. Um, Go through that manual, see how it's supposed to be calibrated. Even DO portable DO meters. I've heard horror stories about people just not calibrating them every day, and they should be calibrated every day. There's a procedure to do that. Follow the procedures. I hope you enjoyed this lesson. Thanks.